Hello, everybody. My name is Alex Velasquez, and I'll be helping facilitate today's webinar. As you know, the title is Simplify F5 Big IP and Cisco ACI Operations using HashiCorp Terraform. During this session, we will explore how to automate end-to-end configuration for a faster, more robust implementation. Please feel free to type your questions during or throughout the webinar on the QA feature below. I hope everybody can see it. After the webinar, I will send a recording. So this webinar will be recorded. It usually takes a couple of days for processing. I have the pleasure to introduce you our speakers. Lionel Erco, he's technical marketing engineer from Cisco Systems. We have from F5, Eric G. He's a solutions architect. And from HashiCorp, my colleague Prakash Mangalanthan. He is senior solutions engineer. As you can see on our agenda today, we will hear about F5 Big IP and Cisco ACI, the challenges when deploying, and how to use infrastructure as code to automate deployment. We will finish with a demo and a Q&A session. And again, as I said, I'm going to be recording, so you'll have a recording after the fact. Lionel will start the presentation. Thank you, Lionel.
Hi, everybody. My name is Lionel Erco. I'm a technical marketing engineer with Cisco, and I worked on all of the third-party integration with our data center networking solution. And today I'm going to start this presentation to talk about the use case we are trying to help with and what are we trying to look into this presentation all the way. So the idea is to bring together Terraform, Cisco ACI, and Big IP to be able to deploy an ADC function application, or ADC function on top of a network, in this case, the Cisco network, Cisco ACI, and to manage all of this using Terraform as the infrastructure provisioning tool, and to be able to apply infrastructure as code principles by expressing our infrastructure as code. So we're going to see how we can use all of those, the tools that Terraform provides to share information in between the different elements and achieve a more automated way of configuring the deployment of both the F5 Big IP on a Cisco ACI network. To start with, I want to talk a little bit about Cisco and Cisco ACI. So I think probably everybody knows about Cisco, one of the leaders in networking around the world and extending into security and a lot of other domains. Cisco ACI is Cisco's SDN solutions for the data center, and more specifically for the multi-cloud data center that expands your data center from your original location, which could be a server room or a full-fledged data center, to remote locations, to also in those remote locations, you could have a peering point like Equinix or a place you rent. And also today, the new data center, which would be either a private cloud or a public cloud portions that might be hosted by you or by a third party. You can see here on this slide where all of the domains that we touch, and we can manage a single pane of glass across all of that, a single network, a single multi-cloud network solutions. On top of dealing with all of those locations, we also allow you to use different type of hypervisor and other solutions like container networking. And in the hypervisor sections, we can do OpenStack, VMware, all of those integrations to be able to extend that networking construct across all of those elements so that we provide you a consistent way of interacting with it and a consistent way of dealing with it. On top of that, everything you can do in ACI can be done through an API, which means that we can provide you the capability to do it through a tools like Terraform. Now I'm going to pass it to Eric to talk a little bit about F5. Eric?
Thank you, Leonel. For those of you who are not familiar with F5, I want to give you a quick level set about what we're doing at F5. So F5's vision is to help customers to deliver application to their users in the most secure, fast, and reliable manner. If you know the Big IP, you probably know us as a load balancer. That's very true because that's the core function of big IP, but big IP is more than a load balancer. Since we are live in the data paths of the application traffic with a full proxy architecture, we are able to host more services in big IP platform. So over the years, we add more services, including both the application delivery service, such as load balancer, global DNS, as well as application security services, such as the web application firewall, secure access, DDoS, anti-fraud functions. So we consolidate all the functions into a big IP platform. So then about 5 to 6 years ago, we started to decouple the software from the underlying purpose-built hardware and make those services available in virtual appliances and also the public cloud, be it AWS, Azure, GCP, what have you. So the big IP will be the focus for this integration, but F5 is more than, so I'm sorry, it's more than big IP. So we are growing our portfolio with our expansion, also some acquisitions. So if you are from the DevOps side, you may know Nginx. We bought Nginx. It significantly extended our number of services, such as the web server, API gateway, ingress controller. It also allows us to put the service into the more modern native container environment. Also, Shape Security extend our security portfolio. Shape can help detect bot attacks, protect users from account takeover, credential stuffing. And most recently, we bought Volterra. Volterra is a SaaS platform that allows us to place F5 services, application services across multiple multi-cloud networking and low edge locations. So you put all things together, we have a broad portfolio around application services. So in a nutshell, so F5 is about application services and security services for multi-cloud environments. So next slide. So as we dealing with application, we talk with a lot of customers across multiple sectors. In our conversations with the customers, we realized that some common patterns, right? So when they move to the new world, embarking the digital transformation, so we saw that there are a consistent set of challenges they are facing. The first set of challenges is the IT operational complexity. So as they moved to the new world, right? We saw that most organizations still have heterogeneous environment. It's kind of like notion of bimodal IT, meaning that they're running both classic monolithic architecture alongside with the modern cloud native architecture. What that means, you see, they're using amazing number of tools to run, operate, and secure the applications. So as a result, it causes an enormous amount of operational burden for IT teams. So not only the lack of standard way to deploy the infrastructure, so they really need a better way to roll back in case the infrastructure fails. So the second set of challenges is about organizational silos. So application delivery is really it's owned by entire IT organization all the way to the developers, right? It's shared responsibility across different teams, be it NetOps teams, SecOps teams, DevOps, even cloud admin. So those different teams, they have different skill sets, different disciplines, and different set of goals, right? So this misalignment often causes some confusion and tension within the organization. It also introduces a big friction in terms of handling off from one team to another. Just as an example, right, for the NetOps team, for Cisco ACI, if they want to make a change, a policy change to F5 Big IP, so in a traditional way, they have to go through the ticket system. That could potentially take days, right? So in this model, so developers have to wait typically for the infrastructure team to provision the network, ACI, load balancer, application services, right? That's on the whole process of the application deployment. Last but not least, that is about multi-cloud challenge. So today, more and more organizations are moving to the cloud, multiple clouds to be precise, right? Because of the scale, because of the efficiency, those infrastructure can provide to the organizations. So it's great to leverage the cloud, but like all other technologies, cloud is not without its own set of challenges, right? So as a result, this multi-cloud challenge provides a challenge for the infrastructure team to handle. So you are challenged with like, how are you going to maintain the security? How are you going to maintain the consistent policy and appliances across different architectures, right? So oftentimes when you move to cloud, IT teams really don't have a lot of control. So ultimately it's us, right? All of like HashiCorp, Cisco, and and F5, all of us to figure out how we can provision, connect, and secure the application with a consistent manner across different clouds. So with that said, Prakash, I'm really interested in hearing from you, hearing about your take on those set of challenge. So what are you seeing? How HashiCorp can help address those set of challenges?
Yeah, thank you, Eric. This is actually such an honor to collaborate with Cisco and F5 and come up with an integrated solution, a kind of a well-tested integrated solution that meets the challenges that that you just mentioned. We know that why we need automation. The challenges you mentioned, they need some kind of automation. Now the question is, what kind of automation? How do you do this automation? And in the industry, we are coming across infrastructure as code is providing the solution, an elegant and proven solution that allows you to codify your infrastructure and leverage code management tools such as VCS, Git, CI/CD pipelines, linting systems to help you automate with confidence. With infrastructure as code, different systems providers have their own tools, but Terraform is kind of the leading infrastructure as a code platform system that allows you to have a single language and a single kind of a unified workflow to provision just about any infrastructure you have. So it could be your AWS, it could be your Azure, it could be your GCP, and now we've always had Cisco and F5, but now with the new integration, you can in a single shot do both of them together. And the diagram on the right-hand side is kind of a very traditional infrastructure as code workflow where the practitioner will write some code. Before, you would go to a UI to click on something to configure it, but now, we think that it's best to write it as a piece of code. Use some modules. We'll talk about that later on, but use pre-written Lego blocks and then bring them together and then provision it through Terraform, which will then spin up, contact the APIs that Cisco and F5 provide to set up everything. And what this brings is, it brings, first of all, brings agility, and then it also gives you confidence that what you're doing to your infrastructure is something that you can track and be confident in it. Next slide. Terraform is quite popular. It's used by some of the biggest companies. We have thousands of providers. A provider is basically a layer that's written on top of the API provided by the vendor. So we have a provider for Cisco, There are actually a number of providers, and then you have provider for big IP, and then you can use Terraform to access these APIs in a declarative way. So that is the beauty of Terraform, is you tell Terraform allows you to configure infrastructure as to what you want to be deployed. You don't have to say what are the steps it needs to take. You just say that I need this configuration in the switch, I need this configuration in these elements, and it'll figure out the best way to give that to you. And you can make a change, and then it'll figure out what are the changes it needs to do, and then provide you that that output. At the end of the day, the main thing is self-service infrastructure. We want to make sure that developers have access to it. So instead of going through a ticketing system, and then you want some change made, and instead of waiting for 3 weeks, you can have the same thing done in 5 minutes. That's our biggest selling point here. People with AWS and Azure and GCP, now they're getting used to, you want on-demand infrastructure, and same with the data center. We can provide that with what Cisco and F5 have done. Next slide. In summary, Terraform provides you increased productivity. That's our biggest selling point here. You are definitely going to save money and heartache and tension between your teams who are waiting for something and it's taking them too long. You're going to have things done much faster with lower risk. Because of automation, you can put in the guardrails, and we'll talk about our Sentinel product that allows you to codify these guardrails. So when you request something, you can make sure that it meets your organization's policies. And at the end of the day, all these tools will help you save money in how efficiently it runs your data center. Next slide. This is our Terraform registry, registry.terraform.io. And here you can go look at the different providers, the ecosystem that's built around Terraform. Obviously, you have, when you go in, you'll see AWS, Google, and Azure, but then you have F5's big IP provider. And if you go and look at it, you'll see sample code. It's very easy to use, and you have sample code on how to use the Terraform provider. Then you have, Cisco has a whole bunch of providers. It's not just ACI, you have a whole bunch of other providers. And there's a lot of sample code there as well on how you can very quickly use Terraform with these different APIs that Cisco and F5 provide. But in the same registry, we also have modules. I'm not sure if the modules we're going to talk about today are published, but eventually they will be there. But modules are Terraform's way of building Lego blocks for your infrastructure, so that you don't have to reinvent everything from scratch. We have this, what we call the producer-consumer workflow, where you could have a team that will write modules, and those are verified. And your consumers, when they need something, they can just pick and choose these modules and then connect them together to achieve this end result. And this is what Eric and Lionel, when they when they come back, they're going to discuss about the unique way they build some of these modules to address the challenges that Eric just mentioned. So when you're working with Cisco and F5, obviously you're not a hobbyist working in your basement. You're going to be a big enterprise, right? You're going to be a big enterprise doing very important things. So Terraform has Terraform Cloud for Business, which is our managed control plane, which gives you the confidence that what you run runs well, it's properly secured, and has all the enterprise needed stuff for you to make changes to your infrastructure with confidence. Of course, it supports Cisco F5 in addition to all the other public cloud vendors. But a key thing of Terraform Cloud for Business is the Sentinel policy as code integration. We won't cover it too much today, but it provides you a language to codify your policies that you may need for an organization. So for example, while we have the Cisco and the F5 modules that for this integration, you can put in Sentinel policies to make sure that they're used in the right way, that certain IP addresses are not used. You may have some restrictions on that, for example, and you can codify those things. So when people start using these modules, you can be sure that they're doing things fast, but at the same time, they're doing it right. So I'm going to pass it on to Lionel, who is going to kind of describe the modules in more detail and go from there.
Yes, thank you, Prakash. So as Prakash mentioned, in this, to achieve the solution of managing together both the F5 Big IP and the ACI Fabric components, we decided to use modules, Terraform modules, to be able to group the different resources that are needed to configure each of those elements. That allow us two things. It allows us to define a very clear boundary between the modules and how we want to expose certain outputs that can be then used as an input to the next module. It also allows us to create dependencies in between the different elements. If we get to the next slide, we can see that we have three modules. So we have one module for the Cisco ACI service graph portion. So that's configuring the network redirection capabilities in ACI to be able to push the traffic in between groups in ACI directly to the ADC, to the big IP in this case, without them to necessarily having to know that there is a load balancer or an ADC function in between. And then we have the two F5 portions. The first one, which will manage how the big IP interfaces are configured, and the second one, which configure the actual ADC service on top of the element. You can see that each of the modules will provide very specific inputs, or you have attributes that you can configure. The way we have been using those modules is also to implement some of the best practices. So some of the default values of a lot of the elements you need to configure have been have a best practice default, but you are able to override any of those elements. A bit later, when we jump into the demo, I can show you where are those defaults, and also how you override those bypassing variables. So that's really the part on how those modules works together. Now, if I dive into specifically the ACI service graph module, the service graph module is kind of divided in three parts. This module is trying to do everything needed in the ACI as if you had no configuration as part of what we call the tenant configuration in ACI, so which is kind of your application level configuration. So we create, with the first portion, it creates the tenant and the networking configs. It can create the tenant, the VRF, which is our layer 3 boundaries, bridge domain, which is our layer 2 boundaries, and the subnets that are the SVIs, if you want, that are in there. EPGs is the way we use groups in ACI to allow and also block things between systems. So EPGs would be, in this case, the client and the web servers that are behind the load balancer. And then we will attach those elements to what we call a VMM domain. A VMM domain is an integration we have with something like VMware, OpenStack, or other systems where we automatically manage some of the configuration on those. If I take VMware as an example, we will configure the port groups on the VDS, and we can automatically assign a VM into that. So that's part of the things we're going to show you, how we manage the connectivity automatically. The second portion is the service graph portion, which is the capability in ACI to actually redirect traffic between two groups into a third node. And in this case, that third elements would be the big IP. And so we configure all of the elements necessary. We instantiate the graph, and then we also configure what we call a PBR policy, which is telling to who do we redirect. And then we configure the also monitoring of that device we redirect to through our health groups and an IP SLA policy, so that if for any reason the one of the big IP nodes were to not work or powered down or any issues, automatically the fabric will not redirect to that node, but redirect to other nodes of that function. And the last part is the part that's bring the things together. It's the contract. The contract in ACI is similar to an ACL. So it allows or block traffic in between groups. In this case, we will allow traffic, but we will allow traffic in a certain way that we redirect it to the service graph. So we attach the service graph to the contract, allowing that redirection. So by doing all of those steps, we create in the module, we simplify all of that by just asking you to input a few variables, and then you will see in the demo a bit later how we get all of those things together. I will now pass back to Eric to talk about a little bit more in details of the F5 modules.
Thank you, Leonel. So before diving into the F5 modules, right, I want to spend a minute talk about F5 approach to automation. So provide a little bit of context for this integration. So on the bottom of this slide, you can see that we call in the notion of automation cycle. So if you look from the left to the right, you see that it's very aligned with the life cycle of provision and network infrastructure, right? Including big IP or even ACI. So each of the phase, so we invest heavily to provide the automation tool chain, right? First, bring the network device, big IP device up, right? That's what we call bootstrapping. So this is where we provide the cloud templates, cloud formation templates or ARM templates for automation. So the next phase is on onboarding. So this is where we have the layer 2, layer 3 parameters configured, right? Making it ready for application deployment. So then moving on to the next phase, we start to deploy the layer 4 to 7 applications. So this is where the developers care most, right? So this is what we want to focus on this integration. So for the this phase, we also F5 also provides a tool called App Service 3 Application Service Extension 3 extension AS3. So what AS3 does is to provide a declarative way to manage the application configuration on big IP. So as this is a piece of software, right? You can download. So when it's installed in the big IP, so it will expose a new set of declarative APIs. So the benefit here is AS3 is for the users, you don't have to have the big IP domain knowledge, right? So you only have to declare the end state of your application. So the AS3 will be there for you. So it's very powerful. So then we have the monitor telemetry stream stage, and also you have make a lot of changes, make changes for the during the operational cycle. So F5 is providing all different tool chains for this entire automation life cycle. So this is the first pillar of the automation approach for F5. The second pillar is about ecosystem integration. So we are working with partners like HashiCorp Terraform to make the networking infrastructure as code. So on the top of the screen, you can see that the very high level of the integration overview with Terraform. So first is day 0 provisioning. So we're using Terraform to provision the big IP in all different types of infrastructure, AWS, Azure, or GCP. So next, we also build Terraform big IP provider. That's what Prakash mentioned. So we use the big IP provider to provision all different services I mentioned for big IP, be it load balancing, application firewall, DDoS, all kinds of services. We can use the big IP provider to automate the provisioning. Next slide, please. So now with the big IP provider in place, we can start build the modules, right? The 2 modules, as Lano mentioned, we contribute to this integration. The first one is the layer 2, layer 3 configuration, the onboarding part, right? Things like VLAN, self-IP, interface configurations. So those things are not very much quite relevant to the developers, right? So we build those things into the module and also abstract those information away from developers, right? So the second module is about application deployment. So this is where we take advantage of the F5 AS3 for the entire abstraction. So then the second thing we did here is, as Leonardo mentioned is build the workflow, right? It's not only about the task automation. We want to use end-to-end automation to define a business workflow to manage the entire automation lifecycle. The benefit of workflow is it removes all the dependencies across different modules. So like Leonardo mentioned, I have to create the service graph from the ACI part, right? So when you create the service graph, so ACI will assign a VLAN to big IP. So then the user, as a user, we have to take that VLAN to configure big IP, right? So this workflow automation will remove all the dependencies. No human intervention in the loop, right? You don't have to care about those dependencies. So this provides a very consistent way between the team managing the ACI and the team managing big IP, right? And finally, with this workflow automation, it enables customers or developers to have this kind of notion, self-service infrastructure. So it means that developers no longer have to wait for the operational team or NetOps team to provision the infrastructure for them, as long as they follows the policies, right? As Prakash mentioned, right? Do it by themselves. So with that, I will hand it over back to Leonardo, and he will take us through a demo.
Thank you, Eric. Let me share my screen. You should be now seeing my screen. So what I'm going to run through is first I'm going to go a little bit more into the code, kind of show you how the modules are, how they work together, how you use that together, and then we're going to use it. We're going to then jump into also the ACI controller, the EPIC, and the F5 big IP to show you what's the result. So first things first is we are providing, as we mentioned, three modules. In this example, we downloaded the modules and they are in a directory, but we will publish some of those modules on the registry. We might slightly make some modifications to make them more reusable, but the idea is we have those different modules. So as we mentioned, the service graph modules from Cisco and the two other modules from F5. To be able to use those modules, we have to create a main .tf or Terraform plan, which is going to try to use the different modules that we need. The first thing that's required, because we are using providers from the registry, is to define which provider and which version do we want from the registry. That's the first section. Then we can start for the ACI module. We will define our provider section, which is going to give us how do we authenticate to the controller. In ACI, we can authenticate with both a password or a certificate. In this case, we are using a password just because it's simpler, but we could directly use a certificate. And we also, the insecure area is mainly for the SSL certificate verification because we are using self-signed certificates. After that, when you have configured a provider, we can configure the module, and that's where we are going to link to the code of the module. And in this case, we would link to the directory, but we could also link to a registry-based element. Or if you use Terraform Cloud and you use a private registry, you could link to your private registry or your module in your private registry. We then pass all of the argument. As I mentioned, there is a bunch of default values that the modules uses, but any of those default values can be overridden by passing an attribute to it. So if you want to change the name of the tenant, like we are doing in this example, we would pass the name of the tenant here. To make it even more reusable, we are passing, in fact, a variable to the attribute so that we can just change the variables. And what we can do is that we would define this variable in our Terraform TFVAR. So if I jumped in the Terraform TFVAR, you will see that my ACI tenant here is called F5. We are in fact using an object as a definition because we allow you to override also the description. So some of those elements are there. You can see here that we are using some of the other elements and some of the systems. If I go back to the modules, so you can see that here we can override a bunch of elements on which domain do we use. So I mentioned the VMM domains, so the integration with VMware to be able to simplify the configuration of the virtual domain, because in this example, the big IP is a VM. And so we want also to pipe the interface of the VM in the right part of the virtual network for that section. We also need some information on the big IP itself. Where do we want to redirect the traffic to the big IP? And then we also need some networks that we are going to interconnect in the system. So all of those variables is what we ingest as a data. When you pass those variables, what happens is that you then get into the module section. And if you look at our service graph module, we have divided it in a series of files to be able to kind of understand the different parts. In the main part, we just create the tenant. We just create that capability so that we can have the tenant there. In the networking, we create all of the networking elements. So remember that slide where I explained to you that there is 3 parts of elements. We're kind of dividing those things here. So we do the networking, we do the service graph, where we push all of the configuration so that we can redirect. When we have pushed all of that configuration, we also gather information, and that's what we are going to refer in our outputs. Because as Eric mentioned, we don't want you to have to run each of the module independently. We want it to flow in between, to create a workflow between them. And so in this case, because ACI configures the VM and the port groups for the VMs, it also assigns VLAN from what we call VLAN pool in ACI, which is just an easy way for you to say, hey, when you create networks, just use VLANs from, I don't know, 1 to 100, and every time it picks a new VLAN and it uses it. In this case, because we're using that, we can just pass the VLANs to the different interface to the big IP module using outputs of module. So that's the part on this, on how we use those elements. Again, as I mentioned earlier, we use a ton of variables. They are all defined in the variable file. So anything that you see defined here can be overridden when you pass the attributes. So there's a lot of them that we have just defined so that it's easier for you. But if you need to override them, just pass the attributes. If I go back to my main.tf and the way we have now looked at the ACI service graph, we can now look at the big IP2 modules that Eric showed it a bit earlier. So again, we define our provider for the big IP, and then we also then define our 2 modules. As I mentioned earlier, we are here pulling from the service graph module the output of interface internal VLAN and external VLAN so that we can pass the VLAN ID automatically. We use a little bit of not magic, but a little bit of function of Terraform to strip and format it the way it's expected by big IP in the module, but this is just do inline by Terraform. Plus a few more arguments, same things. Those 2 modules are located here, and so if we go into them, we can see that what are we doing here? We are in fact generating a template, and we are pushing the template to AS3. And for the self IP, we are configuring the variables. Again, I mentioned variables. We can override all of those elements. Here, in this case, we configure the VLAN interface, and then we configure the IP on those VLAN interface. By default here, as I mentioned in the variable, we use specific ports, but if you wanted to use different ports, you could just pass the variables to override it. Okay, I went over all of the different elements in the main.tf. Now let's have a look quickly at the controllers, to what their state are, and then we can start to use this module. So if we look at the controller, this is Epic. We can see here that we have some tenants already, but we don't have a tenant called F5, which is the tenant I'm going to use in this demonstration. The idea is to show you that it's empty. There's no configuration here. If I refresh, you're going to see that there is nothing. If I go to the big IP, I do the same. I refresh my the elements. You're going to see that the interface of the big IP are not initialized, so you are not able to see they are not configured yet. So let's go back to Terraform and let's start the plan and the configuration so that we can start this element. So I'm going to use the terminal here, and I'm going to do a Terraform apply. You can do a plan if you just want to see, but the apply is going to ask me anyway to check it. So I'm just taking a little bit of a shortcut here. So it's going to generate all of the changes that it needs to be done. There's a lot of configuration that we're hiding in the modules. In total here, you can see that it is asking us to create 41 resources, not to change any, not to destroy any, because it's empty. It was not used before. So I can review any of those change. I can see what the names, some of the names are. If I don't like it, I can quit and I can go change some of the variables. In this case, I'm very happy with it. So I'm just gonna say, yes, please create it for me. It's not gonna run, and you can see here that now it has started creating some of the elements. It has started creating the ACI load balancer, but because some of those tasks can be done in parallel, and we have taken care of that when looking at the workflow, it's already also pushing the AS3 configuration, which is not necessarily linked to the networking config. Then it creates all of the elements for the ACI networks to work, and then and the service graph and all of that. It is now waiting for the fabric to finish pushing the configuration, because as I mentioned, we are pushing port groups to the VMware VDS. We are gathering information on that. And so we have added a small timer just to be able to gather the information, wait for it to be done, gather the information when it's done. So it's taking a few seconds. When it's done, you're going to see that it passes that information into the big IP. And that's because the VLAN configuration on the big IP need that VLAN ID. So it's waiting, it depends on that element. So which means that it's really gonna wait for it. When it gets it, it starts configuring. We are not done, and it's telling me, sorry, I'm gonna move this. It's telling me that I have, sorry, go back, that I have created 41 resources. I don't have any other issues. So if I jump now back to my controllers, let's look at the F5. If I refresh the F5 page, we can see now that 2 of our interfaces has been configured automatically. So interface 1.1 and 1.2, those are the one, if you remember the variable I showed you, that's the one that are configured by default. If I look at the VLAN, you're going to see that I have a VLAN 1343 and 1007 that I used for those interface. And if we looked at the self IP, we will see again two IPs configured. So the networking portions has been configured on that side. Let's check on APEC if we configure also the networking portion. So if I go on APEC, you're going to see that now we have a tenant called F5. If I jump into my F5 tenant, you're going to see that we have deployed an application network profile with EPGs. If I go into a bit more detail, you're going to see that between those two EPGs, we have a contract. And remember, contract is an ACL that allows me also to decide if I want to redirect traffic. And this contains a layer 4, layer 7 service graph, which is my redirection to a load balancer. So all of those things have been created. Another thing I want to show you is I told you we are waiting for some elements to be configured. And this is to be able to gather that VLAN information. And so if I go here in ACI, you are going to see that here for my VLANs, I have 1343 and 1007. If you remember, this is the two VLAN that have been automatically configured. This is not something we pass as a variable. This is something that APEC, or this is the ACI controller, can grab from the pool and decide to use, and then pass it to the big IP VLAN module so that they can configure it properly. So this is automatic. If I destroy it now and I recreate it, it might use different VLANs depending on how fast I wait or I let it create. You might reuse the same depending on how it works. So that's all of the configurations on the ACI elements to make the network works. If I jump back to the big IP, we can also look at the AS3 configuration, which is the service level configuration. For that, we created a partition. So if you can see a partition like a tenant or a portion of the configuration that's separated. And so if I jump to this partition and I now go into, I now go into local traffic, virtual server, I will see that now I have a virtual server that has been created. This virtual server is going to be pulling from web pool. So if I go in the pool, I'm going to see that my web pool has been configured and it has 2 members. The members are not working because as part of the demo, we have not deployed the actual workload, but that would be something that we could easily do, is deploy the web servers on top of it as part of the Terraform, because Terraform allows you to manipulate a lot of other artifacts or a lot of other controllers. So this is really showing you how we can configure all of those elements as a single flow, a single workflow by piping modules into each other. by using modules to abstract some of that configuration, and by using different systems together. That's the strength of Terraform, is using different systems from different vendor, in this case F5 and Cisco, to achieve a single workflow. Now this is great. I'm pushing the configuration and everything, but I think sometimes we also have to remove configuration, and that's where one of the great strengths of Terraform is that Terraform keeps track of state. So if I look here at the state file, you are going to see that I have my state file, which contains everything I have created, and so it knows what it created. It allows us two things. First, if we were to redo an apply, the first thing that Terraform is going to do is it's going to pull from each of the resources that has been created. It's going to refresh the state, and it's going to check if there is any change. In this case, I didn't make any change manually, so there is no change. At the end, it's going to tell me, I have nothing to do, so we don't have to do anything. That's one of the big strengths, is it allows you to just run it in a loop and let you, okay, I don't have anything to do. But now if I wanted to destroy everything, I can just use Terraform destroy. I don't have to recreate a workflow that would do, oh, I have to destroy A, B, C, D, one after the other. No. Terraform is going to use the graph, the dependency graph that it uses to create. It's going to reverse it, and it's going to start to destroy everything. Before doing that, if you didn't say force yes, it's going to tell you what it's going to do. So in this case, it's going to destroy every one of those configuration we have. It gives you a summary at the end. I'm planning to destroy 41 resources. Remember, we created 41. Now we are destroying 41, which is going to get everything destroyed. So I can just type yes, and it's now going to start destroying everything. Going to see that it goes faster than creating, because it doesn't have necessarily to wait for all of the dependencies to take time. We also have removed it doesn't have to wait for getting the information. So we have now resource 41 destroyed. If we look back to the state file, it's now empty. It just contains a version number just to keep track. And if I go back into my big IP and I refresh, I'm going to see that this partition is now gone. I've been dropped down back to common. But so if I look here, I'm also going to get an initialized. If I go back to ACI, you're going to see that the F5 tenant has also going to been removed. So we have cleaned up by moving back all of the elements we have created, allowing us to just go back to our things or to redeploy for another customers. Depending on how you manage your infrastructure, you can use those elements to simplify. If you want to try this exact demo or this exact elements, you can go into this link that we have added on one of the slides, which is F5 Dev Central. That's the current version of the code. You can download it and use it. Some of that will be published, as what's mentioned by Prakash, on the registry as independent module. But if you want the whole solution, it will be there. We're also going to publish this as part of the Cisco Automation Exchange, which is the DevNet portion. If you want to try it and you don't have an ACI Fabric and an F5, you can also use Cisco dCloud. That's what I'm using, in fact, in this demonstration. I'm using, so dCloud is the demo cloud from Cisco. If you contact your Cisco representative for your company, they can give you direct access to the system. So we also have public sandboxes for some of the elements that you could be using to test your system. So I'm just going to go back, ask Alex if she can share the slides back. And I think we are going to go to questions.
Sounds good. Thank you very much for the demo and for the presentation. Questions, I'm going to show the slides in a second, but maybe get started with a question. I know some have been already answered on the chat or on the Q&A feature, but we have one that maybe you touched on at the end of the demo, but still I'll say it. Where would I or should I compose and launch my Terraform configuration to deploy this solution?
So, I mean, you have the choice. You can start with the, if you just want to test and use it personally, you can start by just creating a main.tf file and start to link the modules that you want to use and start to build your element. That's anyway the first start. Once you start to have multiple people that needs to contribute to it, and that it's not only a single your own project, but you have teammates, or it's now an element for the actual team, that's where I think Terraform Cloud makes sense, where you push that code to a repository, like a GitHub repository or any source control system, and then you will link your Terraform Cloud to it, making sure that the state is not on your local machine, but it's stored in Terraform Cloud, and you can then use all of the features of Terraform to be able to provide access to other people, to restrict access, to run some of the policies verification with Sentinel. So that would be probably the decision factor of where I'm going to run those elements. Remember that Terraform Cloud for Business allows you to also run a Terraform Cloud agent, which is a piece of a way to interact with resources that are in your data center. Most likely, your ACI controllers and your big IP might not be reachable from the internet. So that's probably what you are going to look for. I don't know if Prakash or Eric wants to add to that.
Yeah, so as you said, Terraform Cloud is a very good option. There's a free tier and we can help with that as well. But yeah, the cloud agents are a very good option. And if you're in a certain business, you could be the government or something that has nothing to do with the cloud. We also have Terraform Enterprise where everything can be hosted, that's air-gapped from the internet as well.
The question is, as a customer, what factors should I consider for my Terraform deployment if I want to deploy use cases such as this one? Well, I think you touched on that, but if you want to add something to it. Otherwise, we have one last one here. And of course, I encourage people to send any questions that they may have. The basic differences between Terraform Cloud and Terraform Enterprise, I guess Terraform Open Source, and those three. That's another question.
Yeah, I don't know who wants to take which questions. I'm happy to take the one you want me to take, but I think the Terraform questions, I think probably Prakash, if you can just quickly go over those three things.
So I see one question on credentials, and Lionel, I saw your secret for your ACI. That was a good password there, but that was for the demo. It's totally fine. But when you're doing it for your actual enterprise, you can store the credentials in some kind of a secure place. We have a product called Vault, but if you're using Terraform Cloud, we have a way of encrypting credentials and then passing them as variables, so that people can see the credentials. So in Terraform Cloud, you have sensitive variables where you can set up and then protect them.
And if I can just add one thing on that specific note for ACI, we also, as I mentioned, allows certificate-based authentication from Terraform. So which means that you don't even have a password in that time. You need the private key file that would be used for that. So that's also another way to just avoid even using passwords at all. But yeah, Vault and Terraform Cloud do a great job also of hiding them.
Great.
So the one question is, did we answer this? How do you know what modules to use specific to your use case? You need to go over them one way to pick the, I will go over this like Lionel and Eric already showed, right? So for this solution to work, you will need the 3 modules. There are 3 modules that we are publishing and then you would pick them. But yeah, depending on your use case, you have either go to the registry or GitHub and pull in the right modules and then figure out what exactly you need.
Yeah. And I think if I'm sorry, Eric, go ahead.
Yeah, go ahead.
So if I may add on the module side, I think, yes, when there is a lot of modules, I think it can be kind of daunting of which module should I use for what, for which purpose. I think the README of the modules should help you there, try to kind of decide of what it is doing. I think also module needs to be seen as some kind of a template or way to do something, not necessarily as the only way to do something. So because all of the modules are generally published as open source, it's also a way for you to say, hey, I like this module, but it doesn't do exactly what I want. Let me copy it and let me modify it the way, let me fork this repository, let me make it how I want. Because you can always publish either your own module publicly, or you can use the feature in Terraform Cloud to publish private modules just for your organization. Or if you're using the Terraform open source, you can use the module locally in a directory like I showed in the demo. So I think it's really important, I think, to kind of understand those different ways to get modules, because it's very difficult for us, for example, to build a module which allows you to do everything that's needed, but it's also simple. So we don't want to make it overcomplicated. So we might not have a module for every scenario, but we probably will try to have one for the 80% of the cases.
Yeah. So actually, we define the modules, right? We can develop the modules basically, as Leonardo mentioned, is to define a workflow, but that workflow is kind of the best practice from our perspective, right? You can pick and choose whatever module to fit your business need, to address your business workflow, right? So, and one thing I want to point out is about the big IP module. So the second module is about deploy the application, right? So we are using the A3 declaration as part of that integration, that module. So the benefit from there is if you already have the big IP in your environment, so you already have the A3 declaration, right? So you can bring the exact A3 JSON declaration to that module to deploy your applications, right? It does not have to be HTTP. It can be any applications, right? You can leverage your existing JSON payload to use this module. So that's very powerful.
And in a nutshell, module is just a Terraform code. So every time you access it, Lionel had a couple of modules on GitHub, and then we have a whole bunch of modules published. But if you link to it, essentially it's just a piece, a couple of files of Terraform code, and you can see exactly what's going on, and you can extract the best you want to use, and you can create your own modules. So creating your own modules is fairly easy. We have a web page on that as well. Yeah.
Great.
So well, one last question is big IQ supported, Eric? That was a...
Yes, we do have a big IQ Terraform module as well, but we didn't integrate that into this solution. So that's something we can work on if we can define the right use case and put the big IQ as part of the integration as well. But we do have the big IQ resources defined as part of the big IP provider.
And we have done beautifully with time. We're at the hour. Thank you so much to the panelists. Thank you to the audience, of course. Hope everybody enjoyed and are now more aware of how simple it is to deploy F5 big IP with Cisco ACI using HashiCorp Terraform. As I mentioned in the beginning, we recorded this session. It takes a couple of days to process. I will send a copy for you to look at. Again, thanks everybody, and have a wonderful fall.
Thank you, Alex, for hosting us.
Thank you. Bye-bye.